Good morning, children. Today we are going to begin chapter 1 of class 10, and the name of the chapter is Forces, Turning Forces and Uniform Circular Motion. The first topic that I am going to discuss with you, children, is the translational motion or the linear motion. You can also say it as linear motion. Now, what is translational or linear motion? If I ask you and if I define this now, you will say that if there is a rigid body, which is rigid stationary body, which is free to move. This is a stationary rigid body, not moving, which is free to move. Then, on the application of force, it moves in the direction, it starts moving in a straight line in the direction of force. This type of straight line motion the straight line motion of a rigid body on the application of force in the direction of force is called as the translational or the linear motion. So if there is a stationary rigid body and a force is applied to it, then the body moves in the direction of the force in a straight line. This will be called as translational motion. This type of motion will be called as translational motion or the linear motion. Then we come to rotational motion. Children, here the body was free to move and you have applied the force. The body is moving in a straight line in the direction of force. This type of straight line motion on the application of force in the direction of the force will be called as translational motion. But when we talk about rotational motion, then children, if a rigid body is pivoted at a point, and the body is free to turn, not free to move, free to turn this time, free to turn about this point, then on the application of force, the body rotates about this pivoted point. such a motion of the body is described as rotational motion. Means here the body is free to turn about the pivoted point, and on the application of force it rotates about this point. This type of motion, which is described by the body, is turning about that particular pivoted point, will be called as rotational motion. Then we come to children. I am talking about every time rigid body. Now, what is rigid body? What is a rigid body? A rigid body is such a body which does not get deformed on the application of force or a number of forces. So such a body which does not get deformed on the application of a force or a number of forces, you can say, is called as a rigid body. Practically, there is not a single body which is perfectly rigid. Although we take wood, metals, stone, etc. as the rigid body, but these are not perfectly rigid body. Remember this. Now we slowly have to come to our related topics of chapter 1. Now see, number 1 is point of action of force. What is the point of? There will be several times we will written point of action of force. What is the point of action of force? Point of action of force. Point of action of force. Our rigid body is pivoted here, fixed here, but it is free to turn. Now, the force is applied at this point. This will be called as point of action of force. Point of action of force. So, what will be the definition? How can you write this? The point on the body where the force acts is called as point of action of force. Then children, next topic will be line of action of force. line of action of force, when I talk about line of action of force, it is an imaginary line. Line of action of force is an imaginary line passing through the point of action of force and drawn in the same direction in which the force is applied. It is an imaginary line passing through the point of action of force. And drawn in the same direction in which the force is applied. So this is an imaginary line actually. Why we are talking about all these points, I will discuss everything with you, because very shortly I am going to discuss about the moment of force, and all these topics are required here. Then still one principle is there, principle of transmissibility of force. Principle of transmissibility of force. This principle states that the point of action of force, this point of action of force can be transmitted anywhere along the line of force. It states that the point of action of force can be transmitted anywhere along the line of action of force without causing any material difference. It will not cause any material difference. Without causing any material difference in the motion of the body. After these all small definitions and principle, we are now coming to the main topic, moment of force. Moment of force, when I am saying in children, moment of force, a lot of times it has come also in the board exams, and although it's very simple, many of the children write all these things wrong in lack of their practice. See, moment of force. It is the turning effect of the force. Is children, remember that if I am applying a force, it is not necessary that the body will move. So, but there can be an effect, there is always an effect. And because it is pivoted here, there will be a turning effect. So, it is the turning effect of force or applied force, you can say, on a body about the axis of rotation or turning point, you can say. Or the turning point. See, I have pivoted here and I have applied the force here. There will be a turning effect. Will try to rotate the body. Either the body rotates or it will try to rotate the body. So there will be a turning effect of the force, turning effect of the force on the body about the axis of rotation. This turning effect of force on the body about the axis of rotation will be called as moment of force. This only is enough because it already I have written. There is no need to write again. It's called the moment of force. Just the small definition, children. Then we come to anti-clockwise. This is the definition. If I talk about mathematically, what is it? Mathematically, when I define moment of force, then I say mathematically if you are asked mathematically how you can define it. So mathematically it is the product of force and the distance between the line of action of force from the axis of rotation. Children, moment of force is represented by tau. TA is represented by tau letter, and tau is equal to force into perpendicular distance between the line of action of force and the axis of rotation Means what I want to say, think that this is a line of action of force. This is the line of action of force because force is applied here. And the imaginary line passing through the point of action of force, and it is drawn in the direction of applied force. This is the perpendicular distance. So what is the moment of force here? If I say, then F into perpendicular distance between the line of action of force and axis of rotation. We come to children, then there are two types of moment of force: anti-clockwise moment and clockwise moment. If the moment you see in the anti-clockwise direction, like I have drawn here, this is the anti-clockwise direction, opposite to the movement of the hands of the clock. The hands of the clock moves. It is 12 there, and then 1, 2, 3, and so on. It moves in this direction. If it moves in the anti-clockwise direction, if the moment of force, if the effect of moment of force is in the anti-clockwise direction, it will be called as anti-clockwise moment. And if you see that it is in the same direction in which the hand of the clock moves, it will be called as clockwise moment. Children, what is the unit of moment of force? If you know the formula, you can easily find out. SI unit of moment of force, if I talk Newton meter, F is force is Newton, SI unit of force is Newton, and you know that SI unit of distance is meter. So Newton meter. But if I talk, this is the SI system. In SI system we see. But if I talk about CGS system, then children, in CGS system it will be dyne centimeter. Remember, if you are asked that what is the SI unit of moment of force, it will be called as Newton meter. If I ask you that what is the CGS unit of moment of force, you will say that it is the dyne centimeter. Now, if I talk about what is the relation between Newton meter and dyne centimeter, moment of force you know that force into perpendicular distance. I am not writing the whole perpendicular distance between the line of action of force and axis of rotation. If I talk about SI unit, then it is Newton meter, and you know how it has come. If I talk about 1 Newton meter, then 1 Newton into 1 meter, then 1 Newton 10 to the power 5 dyne, and 1 meter 100 centimeter. So 10 to the power 5 plus 2, 10 to the power 2 also you can write. So it will be then called as 10 to the power 7 dyne centimeter. So this is the relation. If you are asked that deduce the relation between Newton meter and dyne centimeter, then it will be used like this, and this is the relation that 1 Newton meter is 10 to the power 7 dyne centimeter. What is the gravitational unit of moment of force? In the gravitational unit of moment of force, children, we won't write Newton meter or dyne centimeter. Gravitational unit of moment of force. If I talk about, there the force is written in 1, if I talk about 1 kgf and then 1 meter, then it will be, children, kgf meter, 1 kgf meter. I'm talking about here 1 kgf, 1 is not that, but kgf is the unit. Force is written in force, unit of gravitational force is kgf and meter. So it will be then kgf meter. But if I talk in the gram force, then we will take here centimeter and then it will be 1 gram force centimeter. Children, you can also write 1 kgf as 9.8 Newton into 1 meter, then it will be 9.8 Newton meter. Means 1 kgf meter is equal to 9.8 Newton meter, whereas 1 gram force is 980 and 1 centimeter, so it will be 980 dyne centimeter. If you are trying to relate with the SI unit or the CGS unit, you can write like this. So children, I am going to now end here. We will discuss about some more topics in the next edition of our class. Thank you so much. Good day.